morning, everyone. My presentation is about the convergence of carbon dioxide emission in China. Okay, let's look at the organization of this presentation. First, I will introduce why I chose this topic. We all know that it is a vital issue for government of the world to make economic growth combined with the environmental protection. The carbon dioxide produced by energy consumption will result in global warming, and which is attained great attention by most of the countries. The important is how to control it. In order to achieve this objective, carbon dioxide emission must converge at a specific target. As the world's largest country for carbon dioxide emission since 2007, Chinese government has set a target for reducing it by 2020 and has begun to make great effort to achieve it. Due to the vast territories in China, the differences of the economic development and resource endowment and so on, the distribution of carbon dioxide emission is varying widely across provinces in China. So it is absolutely necessary to understand the carbon dioxide emission trends across the province. Therefore, it is important to examine whether the emissions of each sector has a pattern of the convergence across province in China. Okay, let's look at what has done by other research. We know that new number papers has verified the economic convergence. Following these literatures, many research has examined whether environmental convergence through the impairment and discrimination studies. These two papers has found that they use the unit root text or the panel unit text to examine whether the carbon dioxide emission has the convergence. They think that it exists. But the other person thinks that the emission across countries or ranges didn't have the convergence. They think even in developed country. So it is very important to understand in the carbon dioxide emission to choose a suitable estimation method and build on considering the character and the sample fully and examine the response of the text. Next, I will introduce my data. Our main analysis is based on balanced, newly constructed panel data of emissions across 28 provinces in China, with dropping some provinces for the missing data. The margin emissions come from the energy consumption, especially fossil fuels in China, so the estimation of carbon dioxide emission is calculated from the energy consumption in some province. According to the IPCC guidelines, for the national gross gas and combining with the statistical characteristic of energy balance sheet of annual China Energy Statistic Yearbook, we conclude the carbon dioxide emission for these equations. EG is about the energy consumption, and BG is the coordination of energy type be contracted into the standard curve. FG is the carbon emission factor of energy type. Our data is taken from the China Statistic Yearbook and the China Energy Statistic Yearbook. According to the sector classification of energy balance sheet of China Energy Statistic Yearbook, we classified the 6 factors as filtered in the table. In the table, we can see that the industry is the biggest emissions. Okay, in order to describe the trend of the carbon dioxide emission development, we start a graph expressions of the relative per capita carbon dioxide emission in each percent. In short, I present the result of the industry sectors. From these figures, we can see that the series show a trend of convergence towards their own means value in this sector. So we get a feeling of the convergence, but we should provide some evidence. So I recite this methodology. The first methodology is about cross-province differences. It is about the delta convergence. It refers to the decreasing of the variation of the cross-province difference in carbon emission level. The delta convergence has two measures on it. The two measures, sometimes the result of these measures is different for some weight on individual provinces performance. So I concluded both of them, and next is for the response text. Next is the text for the beta convergence. We concluded as this equation. The beta refers to the slope coefficient, and the negative value of beta represents absolutely convergence, and the positive value of beta represents a divergence. So let's look at the implemented result. First, the table showed that the SD of carbon dioxide emission in each sectors in 28%. We can see from this table that in all the sectors, the SD of the carbon dioxide emission level has declined. During the 1996 to 2009 in 28 provinces in China. So we think that the emission has the delta convergence. Next is about the beta convergence. We take the beta convergence by OLS and FGLS for its sectors. The result show a negative estimate of the beta in all the sectors, and the significant level of value is above 5%. So we think that the provinces with a relatively low initial per capita carbon dioxide emission level may catch up the provinces with relatively high initial levels. As a result, the differences across provinces may vanish. Okay, that means that they have the convergence in the long run. Okay, we have the two conclusions. First is per capita carbon dioxide emission in all the sectors in China do have the delta convergence, and they also do have the beta convergence. But it not means that China, the government should do nothing. However, we can narrow the gap of the per capita carbon dioxide emission among countries in each sector through differentiated environmental protection. Oh, that's all. Thank you.